All right, everyone. Hello. My name is Praneet, and I'm a rising junior at Irvington High here in California. And the project I built was the gesture controlled car, similar to both the Daniels and another one of my friends. And one of the most important components of this gesture controlled car was the accelerometer Daniel and Theo were talking about earlier. Now, although this accelerometer is very handy, the built-in three-axis gyroscope was the one that was much more useful. The reason being that this three-axis gyroscope read angles in three distinct directions: direction X, direction Y, and direction Z. This means that in order to make my car move forward, backwards, left, and right, or just swerve, I needed to figure out from which I can use this little module to control the entire car. So let me show you how that works in code. Okay, so as you can see on the left of my screen, this portion, this is a little bit of code I wrote. And the first thing I do want to point out is this little segment. So this little segment is converting the initial units of the accelerometer, which is radians, to degrees. And the reason why this was easy to work with for me, so I did that. And then after that, inside the loop, which I created right here, I began with figuring out or playing around with the accelerometer and figuring out which directions were associated with making the car move forward and making the car move backwards. Soon I figured out that was the Y direction. And therefore, I then figured out a range. So any range of values that the serial monitor reads greater than 30 degrees and less than 80, that would make the car move forward. And the serial monitor would print out move forward, as you can see on the right hand of my screen. The same concept can be applied with moving backwards and left and right. Now, if the serial monitor does not read any of these values inside these ranges, then the car will stop as the serial monitor will print stop. And the Z direction I was talking about earlier, this is also very useful. However, I did not implement it in my project since all four directions, forward, backwards, left, and right, were covered. However, one modification, which I will talk about later, I plan on adding will be associated with the Z direction. Now, without further ado, let me show you guys the serial monitor on the right. This is a little bit of a snapshot I took from the serial monitor that was printing out while I was running this. So moving forward, it will essentially print out when I tilt this accelerometer forward. And then right beneath it, you guys can see 35.54 up here. That is the exact degrees of angle I've tilted the accelerometer in. And again, the same concept can be applied with all of these other readings. And I'll show you guys a quick demonstration of my car. So give me 1 second. Okay, so as you can see, this is the car right here. And this is the accelerometer in my hand. So as I tilt this accelerometer forward just a little bit, all the wheels will move forward. As I tilt it back, all the wheels will move backwards. And again, the right and left will work in the same way. However, for right and left, the car will rotate on its axes as in respect to the direction, one set of wheels will completely turn off or move backwards, and the other set of wheels will go. Now, how the P32s are connected and what they are, I believe Daniel probably will talk about that. But something I did want to mention is that I had a lot of fun building this car, and I'm planning to add a lot of modifications, such as a camera, an ultrasonic sensor to detect obstacles, and a laser light, which will be associated with the Z direction. So it can turn around as my car is moving in any direction. Thank you very much for listening. Are there any questions?
Awesome job.
I have a question. So now that you have like an actual gesture control car working, is there a way you think that you might be able to make it airborne, like any time in the future? Are you going to be like researching into that?
That would be extremely cool, Dalen. I can definitely look into that. That's an amazing idea you just gave me. There's still 1 month left in summer, so I might look into that. I don't know why it wouldn't be possible. I mean, what's wrong in trying it out? So I'll try it out and let you know.
Yeah, I have one question. What was the most complicated bug? Because I know so many bugs come up throughout the code, or throughout the project building. What was like the hardest one that you had to overcome?
So the hardest one, I believe, I'm not sure if this was like a foolish mistake or it was actually difficult. So this was the motor driver, which Daniel Wong talked about earlier, was connected to the four motors distinctly. So essentially, I thought that motor driver had short circuited since none of my motors were working. And then later, after around a week of debugging, Theo and I figured out that the problem was with the 9-volt battery pack, and that 9 volts of voltage isn't enough to sort of function all four motors simultaneously.
Yeah, that was a really